Good afternoon, my dear students. So today in this sessions we are going to learn third problem on the 2-bar trusses element. So first of all, I will read the question. 2-bar trusses element as shown in a figure. So in this problem, first of all we need to determine the nodal displacement. The nodal displacement nothing but we need to find out the value of Q1, Q2, Q3 and Q4, Q5 and Q6 we need to find out, as well as element stresses. So we need to find out the value of sigma 1, sigma 2 we need to find out, and support reaction nothing but we need to find out the value of R1, R2, R3, R4 and R5 and R6 we need to find out. Clear here? A force of P, the load is given as 1000 kilonewton is applied. Where it is applied? At node 1. Assume here the modulus of elasticity or Young's modulus value is given as 210 gigapascal. How much is given? 210 gigapascal. And area for each element it is given as 600 mm square is given. How much area is given here? 600 mm square is given. Let us see this figure. Here this is the first node, second node and this is the third node. If you are joining the first node to the second node, we are forming the first element. If you are joining the first node to the third node, we are forming the second element. Clear here? Again here so let us see. Here again we are applying the which force? We are applying the tensile force. Sorry, we are applying the compressive force. Toward which side here? We are applying the compressive force toward the left side at the node 1. At the node 1. So node 1 at which support is acting here? The roller support is acting. If it is roller support will be there, the nodal displacement is acting only in one direction. Which direction? In a vertical direction only. Clear? If it is hinge support, the node 2 and node 3, it is one type of the hinge support or we can say as fixed support. If it is hinge support will be there, they having the two type. One is the horizontal normal reaction is acting, as well as the vertical normal reaction is acting at a point of 2. Come to the node 3. Here, which node is acting here? Here, the nodal displacement Q5 and Q6 is acting. Q5 and Q6 is acting. Let us see the distance between from first node to the third node. It is given as 4 meter. 4 meter nothing but if you want to convert in mm, it should be how much here? 1 meter equal to 1000 mm. How much here? 1 meter equal to 1000 mm. The 4 into 1000 should be become as how much? 4000 mm. Clear? And this height become 3 meter. If you convert in mm means it should become as 3000 mm. Clear here? Then how much load we applied here? We applied the 1000 kilonewton we applied at the node 1. Clear? So in this point we are considering this point as the origin point. If you consider this point as the origin point, or you can consider anywhere, it's no problem, no issues will be there. If you consider from this side, then this value become 0, 0. The horizontal 0, 0. Again, if you want to measure from the distance from the third node to the first node in the x direction, how much distance is given? 4000. In the vertical 0. x1 is 4000, y1 is 0. Come to the node 2. Come to the node 2. Here x1 here or x2 it become as 0, y2 become as 3000. Why? Because in the vertical height y2. From 3 to 2 we have the height is 3000 mm. So x2 is here at this point becomes 0, and y2 is height is how much is there from the bottom is 3000 mm. For that reason we are taking the value of y2 is 3000 mm. So here at the node 1, the nodal displacement q1 and q2 is acting. Meanwhile, the nodal force f1 and f2 is acting at a point of 1. Come to the point at a point of 2. The nodal displacement q3 and q4 is acting at a point of 2, and the nodal force f3 and f4 is acting at a point of 2. Come to the point 3, or come to the point of node 3, in which the nodal force q5 and q6 is acting at a point of 3, and the nodal force f5 and f6 is acting at a point of 3. Clear here? After that, what we need to find out in the step number 1, we need to find out the node data. Clear? So if you observe this figure here, how many nodes we have here? 3 nodes. First node, second node, third node. First node, second node, third node. The distance of the first node from the origin point, how much is that here? x1 is 4000, y1 is 0. Come to the node 2. x2 value is 0, y2 value is 3000. So x2 value is 0, y2 value is 3000. Come to the node 3. Here all value is 0 because we are considering this third point as the origin point. If you consider as the third point as the origin point, this whole the value become as 0, 0, 0. Clear? After that, we need to find out the element connective table. We need to find out the same concept we need to follow here. Already we are discussed in the last class. The first thing is we need to find out the element number. Here how many element we have here? Only 2 elements. This first element as well as this second element. First and second element. So if you are joining the first node to the second node, then we are getting the which element here? First element. Here which one is the initial node? This is our initial node. And this is our final node. The initial node is 1, final node is 2. Initial node is 1, final node is 2. Clear? And come to the element number 2. Come to the element number 2. Here if you are joining the first node to the third node, third node to the first node, third node to the first node. Here the initial node is 3, and the final node is 1. If you are joining the third entities to the first entity, then you are getting the second element. The initial element is 3 and the final element is, or we can say as final node is 1. Initial node is 3, final node is 1. Clear? 3 and 1. If you join the 3 and 1, then you will get the element which one here? Second element. Clear? After that, with the help of formula, you can easily get the value of length of the element L and M. You can easily get. Come to the first element number 1. L is equal to under root of x2 minus x1 whole square plus y2 minus y1 whole square. So x2 here. Come to the first element number 1. Here initial which one is there? 1, and final is which one is there? 2. x1 is how much? 4000 minus x2 is 0. x2 minus x1, 0 minus 4000. Here 0 minus 4000. Again y2 minus y1. y2 is how much? 3000 minus 0. 3000 minus of 0 whole square equal to how much? 5000. Clear? After that we need to find out the value of L. L also we call as cos theta. L is equal to cos theta is equal to, what is the formula is there? X final node minus X initial node by LE. So X final node nothing but x2 minus x1 by LE. x2 how much we got here? 0 minus 4000 by LE is how much we got here? We got the 5000. If you divide this 4000 by 5000, then you will get the value is minus 0.8. After getting the value of L, we need to find out the value of M. M nothing but y final node minus y initial node by LE. This y final node nothing but the y2 minus y1 by LE. So y2 what we can say here, y2 we can say as 3000 minus y1 we can say as 0. 3000 minus 0 by LE what we can say as 5000. If you divide the 3000 by 5000 then you will get the answer is 0.6. After getting the value of L and M we need to substitute in the above. L value is 0.8 and M value is 0.6. After that the same procedure we need to follow for the second element. Okay, for the second element L is equal to which formula we have to use? x3 minus x1 whole square plus y3 minus y1 whole square. So x3 nothing but it is the initial position, 0 minus x1. Let us see here, x3 minus x1. So we can say as 0 minus 4000. Okay, 0 minus 4000. y3 minus y1 nothing but 0 minus 0. 0 minus 4000 whole square plus 0 minus 0 whole square. So after that it become as minus 4000 whole square. If you remove the square and root it become as 4000 mm. After that we need to find out the value of L. L is equal to x final node minus x initial node by LE. So x final node nothing but x1. So here just make the correction here. The final node is here. Here is x1 minus x3. x1 minus x3. 4000 minus 0 by 4000. After that you will get the value L is equal to how much? 1. The same procedure we have to follow here also. M is equal to y1 minus y3 by LE. y1 is how much? 0 comma 0 by 4000. 0 by anything should be how much? It should become as 0. So L equal to how much we got here? L equal to 1, M equal to 1. We need L equal to 1, M equal to 0. We need to substitute in this above element connective table. Clear? L equal to 1, M equal to 0. After getting the value of LE, L1, M1 as well as for the element number 2, LE, L and M. After that we need to find out the element stiffness matrix. What we need to find out here? We need to find out the element stiffness matrix we need to find out. So we have the formula is K is equal to A1 A E by LE, L square ML minus L square minus ML. Okay, then ML M square minus ML minus M square minus L square minus ML, L square ML minus ML minus M square ML and M square. Clear? Then some students is having the confusion how to remember in the examination point of view. It is very easy here. Just do one thing. Just first L square M square in the diagonal you have to consider this L square M square. Again same repeat L square M square. Clear? After that L into M or we can say as M into L. This value, this is a positive value, it become as here negative minus L square. Again this positive value it become as again negative minus ML. Clear? Again I will repeat this diagonal L square M square. Again we have to repeat the same thing L square M square. L square ML, this is the both are positive. After that this value become as negative minus L square and this value become as negative minus ML. Clear? Again this is our, we got the value of M square. This value we have to consider here. This is ML. After that toward this side minus ML. Again this value become as minus M square. Clear? Come to the point of L square. Come to this point of L square. The remaining here which one is there? This whole the value become as minus L square. This value become as minus ML and this minus become values become as plus ML. Over. Come to this last M square. We have to go for in the negative manner like this. First ML, okay, but after that M square. This is both are negative. After that we have to repeat as positive. This positive ML and this is positive M square. Clear here? After that we have to go for element number 1. If you want to go for element number 1, we have to use the formula is K1 is equal to A1 E1 by L1. L square by ML minus L square minus ML. ML M square minus ML minus M square minus L square minus ML L square ML minus ML minus M square ML M square. So after that, the area of the first element, how much we got here? 210. Okay. And modulus of elasticity of a material, how much is given here? I will check it. Here 210 gigapascal is given and the area of the element is given as 600 mm square is given. Is it right now here? Let us see. 210 gigapascal we want to convert in 1 per mm square. Then it should become as 210 into 10 power 3 into this area, how much? 600 by L1 values, how much is there? The length of the first element we got as the 5000. So substitute this value. Which value here? Remember this value. L equal to how much? Minus 0.8, M is equal to 0.6. We need to substitute in the above matrix. If you substitute here, then you will get this matrix. Clear? After that, you first of all you need to divide this whole the value 210 into 10 power 3 by into 600 by 5000. Then you will get the value is 2100. Okay, you will get. Clear? After that, 2100 into 12. So if you are 2100 into 12 into 0. So dear, don't be confused here. Just you need to multiply in the above matrix. So here only, then you will get a 0. Above how much we got here? This one K1 value is how much we got? 0.64. like this value same as it is only. And this K2 value how much we got? 2100 into 15. We are substituting in the same equation A2 E2 by L2. Then you will get this value is 2100 into 15. Then you will get 00 minus 10 00 00 and minus 1 0 1 0 0 0 0 and 0. Then how to write? That is the most important here. Don't be confused here. This K1 value already we got the value is how much? 2100 into 12. Clear? So this 1 and 2 it is considered as node number 1. 3 and 4 we can say consider as node number 2. Clear? After that 1 2 3 4 again 5 6 1 2. Clear? This 5 and 6 what we can say here? We can say as node number 3 and 1 and 2 we can say as node number 1. That's it. The same concept whatever we followed in the last class. After that we are getting the value of K1 and K2. We need to substitute in the global stiffness matrix. The global stiffness matrix K is equal to the elemental stiffness matrix of the first element plus the elemental stiffness matrix for the second element. So K1 value how much we got here? 2100 into 12. Okay, and then this value is 7 point. So this 2100. After this 12 we are multiplied with 0.67. If you multiply then it becomes as 7.68. Again if you multiply 12 into 0.48 it becomes as minus 5.76. Okay, if you multiply 12 with minus 0.64 then you will get the value is minus 7.68. If you multiply 12 with whole the value then it becomes as this figure. Again remember, again we need to multiply in K2 15 into whole the matrix. 15 into 0 it becomes as 0. 15 into minus 1 it becomes as minus 15. And 15 into minus 1 minus 15. 15 into 1 it becomes as 15 only. Then after that this is a 1 2 3 4. We can write here 1 2 3 4 5 6 1 2. But this matrix we have to write in the systematic order. Then how to write? That is the most important. First of all you have to write here first, second, third, fourth, fifth, sixth. In the row you have to present 1. So in the column you have to present like this 1 2 3 4 5 6. here row 1 2 3 4 5 6. Then how to multiply? Let us see over here. 1 into 1, it becomes how much we got here? 7.68. Again 1 into 1 is there, it's available here. Yeah, it is available. 1 into 1 here also available. How much we got as 15. So we need to add here 7.68, this 7.68, again this 15 we need to add here. Again 1 into 2, 1, this 1 into 2, how much we got here? Minus 5.76. Again check it here. 1 into 2 is there, yeah, it is available. 1 into 2 is value is 0. Clear? 1 into 3, how much you got here? Minus 7.68. Okay. Again 1 into 3 is there, not available. Keep as it is. 1 into 4 is there, yeah, it is there. How much? 5.76. 1 into 5, it is available. One check it. 1 into 5 is available. How much? 15. So 1 into 6 is there, not there. Yeah, 1 into 6 is there. How much value? What is the value is there? Value is 0. Clear? The same concept we need to follow up to the bottom also. 2 into 1, how much we got here? Minus 5.76. Okay, again check it here. In this matrix, 2 into 1 become as 0. Clear? And 2 into 3 value is how much? 5.76. And 2 into 4, if you multiply this 2 and 4, it become as how much? Minus 4.32. And 2 into 5 is available here. Yeah, it is. This side is not available, but this side is available. 2 into 5 value how much is there? 0. 2 into 6 value how much is there? 0. Clear? Come to the same procedure. 3 into 1, how much you getting here? Where the point is intersecting, this 3 and this 1 is intersecting at this point, then you will get the value is minus 1.68. 3 into 2, this 3 and this 2 is intersecting at this point, then you are right here. 3 into 2, then you are getting the value is 5.76. 3 into 3, you are getting the value is 1.68. 3 into 4, you are getting the value is how much? Minus 5.76. 3 into 5 is available here, not available. This side also available, not available. If it is not available, then you need to consider as 0, 0. Then again the same concept you need to follow for the 4th, 5 and 6th also. After that, add this value 7.68 plus 15, then you will get 22.68 minus 5.76, 4.32 minus 5.76. The same matrix you have to present here. After getting the value of k, again what we need to find out? We need to find out the equilibrium equation for the given continuum. We need to find out. If you want to find out the equilibrium equation for the given continuum, we have the formula is kq equal to f. K nothing but the global stiffness matrix into nodal displacement. Here how many points we got here? 6. So for that reason we can represent here q1, q2, q3, q4, q5 and q6. And the nodal force is f1, f2, f3, f4, f5 and f6. Clear? Then so at node 1, which type of the support will be there here? The roller support. If it is roller support will be there in the x direction is unknown, but in the vertical direction value become as 0. For that reason we need to eliminate the second row, this second column. Clear? At node 2, node 2 has also, how it is there here? It is the fixed support, or we can say as the hinge support. If it is hinge support will be there, then this q3 horizontal and q4 also 0. q3 and q4 also 0. For that reason we need to eliminate this third row into this third column, and q4 also 0. This fourth row into this fourth column will cancel. Again at a node 1, in which type of support is there? Roller support also there. For that reasons q5 and q6 value become as 0. Let us see here. Here not roller support. At the 1 is roller support is there. At 2 and 3 which support will be there? Hinge support will be there. Is it right? For that reason this q5 and q6 value become as 0. If it is 0, then that's what we need to eliminate this 5th row and this 5th column. Clear here? So please write, small mistake is here is there, just rectified here. Node 3, Let us see. Here make as the, this is node 3, not node 1. Q5 and Q6 also 0. Please then make the small correction here, dear. Here at a node 3, okay, Q5 and Q6 value become as 0. After that, let us see 2100. We are getting how many point only? Only 1 point only. Is it right? Which one? Only 22.68, not eliminate from the vertically. For that reason, we need to take this value 22.68. Just you to multiply with Q1. Q1 equal to minus 1000 into 10 power 3. After that, this value you need to multiply 2100 into 22.68. If you multiply, then you will get the value is 47,628. Q1 equal to minus 1000 into 10 power 3. So if you divide this value, then you will get the value of Q1 is minus 20.996 mm. After getting the value of Q1, here Q2, Q3, Q4, Q5, Q6 also 0, because our intention is we need to find out the value of Q1. Q1 how much we got here? Minus 20.996 mm we got it. After getting the value of Q1, we need to find out the value of stresses in the each element. So this means that we need to find out 2 element, because we have the 2 element. For that reason, we need to find out the 2 stresses we need to find out. So same formula we have to follow. We need to follow here. Sigma 1 equal to E by L1 minus L minus M L M Q1, Q2, Q3 and Q4. We can say as the node displacement Q1, Q2, Q3, Q4. That's what I am representing here, the node 1, 2, 3, 4. And the E's indicate that modulus of elasticity or Young's modulus value is given as 210 into 10 power 3. The length of the element is given as the first length of the element is given as 5000 minus L. So this minus L we have to take from the tabular column for the first element. Okay, L is how much? Minus 0.8. M is equal to how much? 0.6. Okay, this is L well nothing but minus 0.8, M nothing but minus 0.6. Clear? N nothing but minus 0.8, M nothing but 0.6 only. Clear? Q1 value already we got how much here? Minus 20.996. Q2 value is 0, Q3 is 0, Q4 also 0. After that, if you divide this both the value, then you will get the value is 42. Minus into minus, it become as positive. 0.8 into 20.996, it become as 0.8. Minus 0.6 into 0, it become as which one? So there is, always remember, just read this row into this first row only. This no need to multiply this whole the value. Only 0.6 into how much? 20.96. Okay. Here you will get them. Let us see. It should be become a sorry dear. This is 0.8. Again this minus 0.6 into this second row, or we can say as second column into this second row. Minus 0.6 into 0, it become as 0. 0.8 into 0, it become as 0. 0.6 into 0, it become as 0. Clear here? Then again, just you need to multiply here 0.8 into 20.996. Then if you multiply with 42, then you will get the answer is minus 705.47 Newton per mm square. After getting the value of sigma 1, so sigma 1, how is the nature? The nature is compressive force is acting on this component. Come to the for the element number 2. For the element number 2, the same concept we need to follow here. The same formula we have to use. Clear? Sigma 2 is equal to E by L2 minus L minus M L M Q5, Q6, Q1 and Q2. Clear? Then E nothing but the modulus of elasticity of the materials is given as 210 into 10 power 3. Length of the second element is given as 4000. So L of this second element, which element here? For the second element, how much is given here? Let us see. For the second element is given as L equal to 1, M equal to 0. L equal to 1, M equal to 0. L equal to 1, which one? Minus 1. Minus into minus it become as plus 1. M value is 0. Again here L nothing but minus 1, M nothing but 0. And Q5 is become as 0. Q6 also 0. And Q1 nothing but already we got the value is minus 20.996. And Q2 also 0. Again, if you divide the value 210 into 10 power 3 by 4000, then you will get the answer is 52.5. Just you need to multiply 1 into 0, it become as 0, 0 into 0, it become as 0, minus 1 in minus into minus, it become as plus, 1 into 20.996, it become as 20.996. Not in the minus, it become as plus only. 0 into 0, it become as 0. If you multiply this value, then you will get the answer is plus, not in the minus here. How much? 1102.30 Newton per mm square. After getting the value of plus value, then you to consider as the tensile force, not minus here, make as a plus, make the small correction here. After that, we need to determine the normal reaction forces. We need to determine. So here at the node 1, the roller support is acting. For that reason, the normal reaction is acting in the upward direction, as well as here at node 2 as well as at the node 3, it is the hinge support. For that reason, the normal reaction is acting in a horizontal direction as well as in the vertical direction. Clear? So first of all, we have to write down normal reaction R is equal to KQ minus of F. R nothing but the normal reaction R1, R2, R3, R4, R5 and R6. K nothing but the global stiffness matrix, whatever we found in the above. The same thing we have to represent here. Q nothing but the nodal displacement, the Q1, Q2, Q3, Q4, Q5, Q6. This Q1 value already we found how much? Minus 20.996. Q2 is 0, Q3 also 0, Q4 also 0, Q5 also 0, Q6 also 0. Minus the nodal force, how much we got here? Because at a point of 1, the normal force is acting. How much force is acting? Minus 1000 into 10 power 3 Newton is acting here. The force, because there is no force is acting at a point of 2, there is no force is acting at a point of 3, there is no force is acting at a point of 4, there is no force is acting at a point of 5, there is no force is acting at a point of 6. For that reason, the value become as 0 only. So after that, if you simplify this value, because you know how to simplify, just you need to multiply this value 22.68 into minus 20.966, then you will get some value. Again this row into this first value, this second column into this second row, this third column into this third row, the fourth column into this fourth row, fifth column into this fifth row, and sixth column into sixth row. You need to multiply, then you will get this answer. After that, again you need to subtract this value, then you will get this. After the simplification, you will get this value. R1 value, how much we got here? R1 we got the answer is 0. R2 we got as 253.97. R3 we got as 338.62. R4 is minus 253.97. R5 is 661.38. R6 also we got as a 0. So after getting the value of R1, R2, R3, R4, R5, R6, after that we need to write down the result. This is up to conclusion is completed. After that we need to write down the result. Result is the most important, scaling for the 3 to 4 marks in the examination point of view. If you represent the result, the examiner examine that you are whatever you written, the each and everything should be detailed only. That's what he didn't cut your marks. Is it right? So for that reason you have to represent this result, because the result is having the positive impact on your marks. Is it right? The nodal displacements are, we can consider as Q1 value is how much we got here. Q1 value is already we got as minus 20.996. Q2 value we got as 0, Q3 0, Q4 also 0, Q5 also 0, Q6 also 0. After that we need to find out the value of the normal reaction. The normal reaction we got the value is 0, R2 value is 253.97, R3 value is 338.62, R4 value is minus 253.97, R5 value is 661.38, R6 value is 0. After the finding the value, we need to find out the sigma 1, sigma 2 already we find. How much we find here? sigma 1 value is 705.47 Newton per mm square is in compressive nature, and this value is in tensile nature. Sigma 2 is equal to, make the correction positive, 1102.30 Newton per mm square. Okay dear, I hope so no one is having a doubt up to this class. If you have the small doubt also, you can write in the comment box, and please don't forget to like and subscribe my channel dear. Thank you.